Alright, good morning. How's everyone doing?
Forgot another ODP.
Ah, okay. Well, we got another one that opened today, so. So yeah, let's start by looking at the current ODP.
Ooh, damn.
Which should be ODP. I thought it was 306.
5, man.
305. All right. So 305 is going to play further with this idea of stateful programming. And so you're creating a class named states, and there's going to be an integer that you're going to keep track of in this class, and I'm just going to call it state, or call it result. You can call it whatever you want. But there's going to be an integer you're going to keep track of. That's going to be basically the state, part of the state of the system. There's 4 things that you can do with this class. You can ask for the current value of this integer called result, and it just returns it to you, so that's just a getter. You can call process and pass an integer, and that integer will either get added to or multiplied by the result. So this is a running sum or a running product. So if my result is 0 and I say process 5, it would add 5 to the result. Now result would be 5. And if I say process 10, it'll add 10 to the result, and result will be 15. And by default, every time I call process, it adds to this internal integer. But if I call this method doMul, it changes the behavior of process. So the next time I call process, the current result gets multiplied by n. And then if I call process again, that last current result will get multiplied by this value of n. And then if I call doAdd, nothing happens, but the next time I call process, the number I pass gets added to my result. So result never gets reset. It's just a running sum or product that starts off at 0. And every time you call process, it either adds n to the result or multiplies the result by n. And which of those does it do? It depends on whether most recently you called doAdd or doMul.
Are these going to be, what, public functions, right?
Yeah. So everybody get the behavior of these 4 methods and how they interact?
Pretty straightforward.
Okay. So that's really the whole class. It doesn't need a constructor. You just want to initialize your internal integer to 0, and then these 4 methods do what's described. And so as an example, right, I might create a new state. I might say process 5, that'll add 5 to 0, result is 5. Process 7, that adds 7 to 5, which gives me 12 in the result. And then I switch to multiplication. If I say process 3, result is now the current value 12 times 3. So now result is 36. If I say let's do addition, then when I say process 1, it adds 1 to 36, gives me 37. Now I say do multiplication, process 10, it takes the result 37, multiplies by 10, gives me 370. Now if I say let's print out s.result, it'll print 370.
So does doAdd and do multiplication basically just change? Well, the way I think about this is kind of compare like the Boolean expression to see whether an operator are in like addition or multiplication, and then do like the if statement inside of the process.
Perfect. Exactly right.
Okay.
Yep.
Or
So
is there a better idea?
no, that's exactly the way that I think you should do it. So doMul and doAdd simply update a flag, which is what we mean by state, right? Set a flag or clear a flag or something to say, hey, you know, next time you're in process, you want to add, you want to multiply. And then in process, check that flag and either do your add or do your multiply.
I don't think we
Yes.
Okay.
Yeah, the question mark symbol for doing an if-else. All right, compile your code, test it with, some sort of test program, and then assess it with this magic assess command. And we've already got some 10 out of 10s on it, so awesome.
Wasn't I? Come on, ternaries are perfectly readable. You can't read ternaries.
I'm still trying to get used to using ternary operators, and I haven't used it in forever, but I feel like
They're just for simple things. It's super easy.
so do you just put like an expression, then, or is it a question mark, then expression, or is question mark, then question mark?
Question mark first and then colon.
I'll also look up syntax for that.
So yeah, ternary operators, they're a nice shortcut, and they basically have, some sort of thing that evaluates to a Boolean for Java. For C, they just evaluate to an integer. But a Boolean for Java, question mark, tval colon fval. And this whole thing basically takes on either tval or fval depending on the value of expression. If this is true, it becomes tval. If it's false, it becomes fval. And you can do other things in here besides values. You can actually get it to execute code and such, and start getting super sneaky like that. But it's typically x equals y equals 0, interrogate x plus 1 colon x minus 1. So if y is equal to 0, x equals x plus 1, else x equals x minus 1. This would be a shorthand way of doing it. Yeah, and so with these ODPs, I'm trying to open them on Canvas once they're open, and so if you start working on a different ODP, right? Yeah, you can clobber your already perfect score on a previous ODP. So when you do assess, make sure you check the little blurb in the beginning saying you're about to assess for, and there should be a little synopsis of what the assignment is. You missed ODP 305, and we're just finishing that up now. All right, cool. Any other questions on that?
Can you kind of go over the recursion method for binary trees, and kind of like the process of being able to, well, trying to think of a good question for this. It's like, can you kind of explain to me about I was going to say algorithm, but I think the better word would probably be like how to create a recursive method in Java.
So part of what I want to do today is build up a set of classes for a binary search tree, which is a little different from the decision tree of PA3. But I want to do a binary search tree example, and that will definitely be recursive. We'll do like recursive traversal and such. So we'll actually put some code together that involves what you're talking about. So if we can hold off for a few minutes on that, we'll do that as part of a bigger topic.
Okay. So I remember back in 222 when we did a knapsack problem.
Mm-hmm.
So I think I really remember it because the algorithm for it is I sometimes forget.
Mm-hmm. Recursion in Java is pretty straightforward in that we don't have to do anything special. I guess it's kind of that way in C also, but it's really just you know, calling a function that you happen to be calling from itself. But if we have a function that's supposed to do, you know, X, and we want to do X, we call the function. And recursion is nothing more than the kind of peculiar oddity that, you know, we happen to be describing how we want to do X. And part of how we describe that is by doing X. Well, that's a little peculiar, but in terms of coding it, you know, you want to do X, you just call a function or a method X, and it does its thing. So, but we'll do that. We'll look at recursive traversal and recursive insertion into a binary search tree. Very similar in style to what we did in 222.
Was the topic of that question related to PA 3 or ODP 305?
More on the PA than the ODP. The ODP has nothing to do with recursion.
Okay, good.
Yeah. And 305, we really just kind of read through the README, and I wrote some things on paper that are from the README basically. So just look through that, and it should be mostly self-explanatory.
I do have a question though.
Yeah.
So I remember you. A cool trick with if statements is that you can create like an if statement with only like one line what's it called, like a one-liner or something like that.
Mm-hmm.
Where you don't need to use curly brackets. Does that same rule apply for methods?
I don't think so. I think you always need curly brackets for methods and for classes.
Okay.
And I strongly recommend putting them in for if statements too. Even if it's only a one-line if statement, and I really strongly recommend putting them in for loops, even if it's a one-line loop. I don't know if Java lets you get away with it. I know C lets you do a one-line loop without curly brackets, but it can bite you when you least expect it.
Yeah, I can imagine, especially if you make an accidental head that amend the account.
Mm-hmm.
Or what
Right.
goes on, you know, the loop in class or whatever.
The typical thing is, you know, if X equals 0, flag equals true. And you've got this in your code, that works perfectly fine, but you're trying to debug it. And so you add a print statement, you know, print X is 0. And you forget to add curly brackets. Well, now flag is always being set to true, right? Because now your if statement is just saying if X is 0, print X is 0. And whether it prints it or not, flag is going to get set to true. And now you've introduced a bug into your code by virtue of trying to debug it. And if you had done curly brackets, you would avoid that slight mishap. That's the only reason I say I prefer curly brackets.
I got a different question.
Okay.
So, for making the public static void main with the args for getting arguments from the command line,
Mm-hmm.
do we need, is it kind of going back from what we did in I think it's interesting 222 or 224.
Mm-hmm. Probably 24.
Where maybe 224. Where you have to check the amount of arguments before you check what
Mm-hmm.
You check like the amount of arguments being passed to a function before you check each of what they are.
Absolutely.
So does that same rule apply for Java, or do we go straight to doing argv bracket 0, for example?
So you know, suppose I've got my main method. And suppose I say if args bracket 0 dot length is bigger than 0, do some stuff, right? If there is no args bracket 0, this is going to give me an error. It's going to throw a null pointer exception. So this is not the right way to see if there's an argument specified. Before you do this, you should do something like if args dot length is equal to 1, then let's go ahead and see if this first argument is non-empty, for example, or is equal to something or whatever. But yeah, anytime you work with an array, before you work with element I, you want to make sure that the length of the array is at least I plus 1. That's regardless of Java, Python, C, Fortran, anything, right? Anytime you use an array, make sure that if you're going to access element I, that element I actually exists. So in C, when we're dealing with command line arguments, we check the argc argument. In Java, when we're dealing with an array named x, we can check x.length, which tells us how many elements are in this array. And so yeah, if you're not absolutely sure that this element exists, you always want to compare it to the length of the array to avoid an exception.
Okay, thanks.
Mm-hmm.
I keep thinking of argc whenever I think about command arguments, but I'm assuming that when it comes to I'm assuming object-oriented programming, it's a little different. Is that fair?
The only real difference is, you know, in C we do this. Right? In Java we do this. So instead of argc, we can do args.length. And instead of argv, we're just calling it args here. But I mean, we could call this argv if we want, and then it would be argv bracket, you know, some index to get an argument. And argc, which is how many things are in this array, well, that's just args.length. In any array, we can say array.length to see how many things are in the array.
Question, Nick.
Yeah.
What's the difference with C? We had like when we compiled, we did it like we have arguments and stuff. Or rather, when for some programs we ran it with like different arguments in the command line. C. What sorts of things would we do for arguments if we in the event that we have to do that in Java?
So in Java, if I say like Java PA3 blah, right? Then inside my main method, if I said string bracket bracket args, args will be an array of strings, args.length will be 1, args bracket 0 will be the string blah. And so in C, you know, I just type the name of the program followed by arguments. With Java, I say Java, the name of the class, and then I put my arguments right after that. And so in PA3, for example, you have an optional command line argument. If I say PA3 blah, then this is the database file we're going to use to play the game. If I don't have an argument, then we're going to use 20q.txt. So in the start of PA3, I would check args.length. If it's equal to 0, my file is 20q.txt. If it's equal to 1, my file is whatever args bracket 0 is. If it's 2 or greater, the person put extra stuff on the command line, I would just yell at them and exit and say, hey, you can put 1 argument or no arguments.
Okay. That's good to know. However, it's not quite what I was asking.
Okay.
What I was more so wondering was, I'm assuming that this is probably going to be a yes, but are there cases where you don't put in like the name of like a .txt file as an argument? Like, are there other things?
For PA3 or in general?
In general, for Java.
In general, your arguments could be anything that you want them to be. It could be. Sorry, say again?
They're not always TSC files, though, right?
Could just be an expression, could be a word, could be a Unix command, could be a password, could be a set of numbers. There's no requirement for what your arguments are. But in your main program, they're always treated as strings, right? So whatever symbols you put after this, that set of symbols, you know, up to the first space, that goes into args bracket 0, and it's a string. If it's a hexadecimal number, you could use, you know, integer.parseInt to change it into an integer internally and so on. But it's the same as we saw in C, where this is basically an array of strings, or an array of car stars in the language of C.
Is there a string open close bracket args like class or documentation file for like as like different like methods for interpreting arguments that are like different data types or whatever that are passed in.
So this is an array of strings. The only thing we really need to know about arrays at this point is you can say array.length to find how many things are in there. But then if you say array bracket, you know, some index, it's just a string. And all the methods that you find in the string class, those are applicable to say args bracket 0, args bracket 1. But there's nothing special about the fact that this is, you know, the argument list for the main method. It's just an array of strings. It's like any other array of strings. And there's nothing special in Java about command line arguments. It's really just as if this main method was called with, you know, an array of strings as its parameter that you're sending into it. And it really has no interest in whether these are the names of files or, you know, numbers or whatever else. This is all main agenda. No, these questions are good. All right. Yeah. Say again?
I said I got 10 out of 10 on it.
Awesome.
I still realized that when it comes to ternary operators, you have to have a result equal something. Where, because I looked up on my.
Right. Yeah, the ternary operator basically replaces this whole thing with either that or that. So usually we see this on the right side of an assignment statement. But not necessarily. You could put this as the argument to a print statement or a parameter that you pass to a function or wherever it makes sense.
Well, it gave me an error if I don't put, if I just only put the expression with the question mark and then the true or false values. I mean, it throws an error at me saying that the expression is incorrect or something like that.
Yeah, it would be like writing a Java statement like, you know, 2 semicolon. Well, the compiler wouldn't know what to do with that.
Yeah, in other words, kind of like, where do I save the result in? The idea.
Right. Or should I print it, or should I return it, or should I pass it to something? But you got to tell me what to do with the result of that ternary operator. I call this interrogation, and I don't see that word much, but Kernighan and Ritchie, that's what they called it in their first C book. It was called interrogation. So, I don't know. It's another word for it. It makes it a verb instead of a noun. All right. Any lingering questions from PA2?
Possibly, I'll think of it when it comes up, though.
Okay. All right. So PA3 we went through sort of a first pass of that, and I want to dig further into PA3, but I also want to do an example of creating a tree class in Java. So PA3, right, we're going to implement a decision tree, so it's this yes-no tree. And to think about how we want to structure this, I want to look at an example class, and this is not going to be a tree class you can use exactly in PA3. Let's make a class of binary search trees. So very similar to what we've done in 222. So we're going to make a tree of integers, and it's going to be a search tree, so things to the left will be smaller than the root, and things to the right will be larger than the root. And this is not the tree you're going to use in PA3, right? But I want to give you this as an example. I want to develop this set of classes to give you some ideas to think about how you can structure your decision tree for PA3 in terms of a tree and nodes and a main method and so on and so forth. So this will not necessarily be what your code looks like. So let's make a tree class. So we're going to build a class named tree, very imaginative name. And to construct a tree, we're just going to say new tree. And then I want to make some add methods. So let's add some data. So we'll call the add method on the tree to add some data. And then we're going to do an in-order traversal, because we know that if we do an in-order traversal, we should get minus 50, 1, 2, 88, 100, and 92, 783. They should come out in increasing order. And so to print in order, I'm just going to say t.print. So this will be left node right. This is not the traversal order you need for PA3. PA3, when you write your decision tree to a file, you're going to do pre-order, node left right. So this is another way in which this example is not part of PA3. But this example is very much the code that we've done in 222. So I want to leverage our 222 tree experience and just see how we could do this in Java. So here's what we would like. We'd like a class named tree that has an add method for adding data and a print method for printing the tree. And you can imagine, there could be a search method that would return a Boolean. There could be a delete method for removing something, and so on and so forth. But this is how we want the user to see a tree. So construct the tree, get this tree object t, and then call its add methods and its print methods. And there's two sort of complications here. The first complication is, when we construct a tree, we have this object t, but it should represent an empty tree. Right? Now t will not be null, but it should represent a tree containing no nodes. So that's the first thing to keep in mind. The second thing is these add and print methods, which are going to be recursive, need to operate on, if we say t dot print, for example. So we gotta dust off our neurons on our tree. So here's our tree T, right? And typically, you know, there's going to be some root node, there's going to be something to the left and something to the right. So what's our recursive way of printing our tree? First thing we're going to want to do is print T left. And then we're going to want to print out the root data, and then we're going to want to print out T right. Well, T left is what? It's this thing right here. It's actually a node, right? It's a thing that contains a value and a pair of pointers to the left and the right. And this whole thing is a tree, but this thing on the left is actually a node. And so I'm going to need a pair of classes, just like I did for a linked list. I'm going to need a tree class, and I'm going to need a node class. And when I say, let's, you know, print this left node, well, if this thing has children, I'm going to recursively say, let's print this thing's left child. Well, that's a node, right? And so these nodes themselves are going to need a print method. And when I want to add to my tree, if I'm adding something bigger than the root, I'm going to call the add method on this right child. Well, this right child is a node, so I'm going to need add methods in my node class as well. So I'm going to have a tree class, and that's going to be comprised of nodes. And in my node class, I'm going to have things like add and print. But from my main program, I don't want to say, you know, tree.root.add or tree.root.print. I just want to say, you know, name of my tree.add or print. So I'm also going to have an add method up here and a print method up here. And these are really just going to be wrappers around add and print methods in my node class. And if this isn't making perfect sense, that's okay. But this is the basic setup that we're going to build. And once we build it, I think it'll make more sense. But that's kind of where we're heading. So here's our tree class being used. Let's go ahead and make our node class next. So we'll make a node.java. All right, so what are the pieces of a node? We need a data field, which for us is just going to be an integer. And then we need left and right children, and those left and right children are going to be nodes. So this is node left and node right. And again, for PA3, it's a decision tree. Our nodes are going to be called yes and no. Yes will be to the left, no will be to the right. But this is a 222 binary search tree, so we're sticking with children called left and right. And I'm going to make a constructor that'll be particularly useful. So I'll say public node, and I'm going to construct by passing an integer. And what this is going to do is set my data equal to that integer, and set my left and right children equal to null. And that'll be how I'll construct most of my nodes. Because usually I don't just want a node, I want a node that holds a particular value. So if I want to make a node containing 17, I'll just say, you know, node n equals new node 17. It'll set the data value to 17, it'll set the children to null. Alright, so here's our recursive in-order traversal. Alright, so how do we traverse a tree from a given node? And we don't have to worry about the possibility that node is null. Node cannot be null, because what we're going to do is we're going to have a node named, you know, Barney, and we're going to say Barney.print. Well, once we're inside this print method, we know Barney exists, otherwise we couldn't be here. And so we don't have to worry about the node being null because we can't execute this method unless there's a node we use to call it. So we always know that there is at least one node, but the left child could be null. And if the left child is null, we don't want to traverse the left subtree. So this is a simple if statement. If left is not equal to null, let's call the print method on the left subtree.
You have to repeat that process for all 3 nodes?
For the left and the right.
Just for the left and right, not for the... Oh yeah, well, we don't need to check the parent, right?
Right, right. So the node itself exists, and to print the root node's data, we just print the data. So this says recursively print the left subtree if it exists. Repeat my typos. So if the right subtree exists, we'll call the right subtree's print method, and that'll recursively print the right subtree. And in between, we want to print the root node's data. And we can just do that with a print line. There's no need to recurse. So this is the basic left node right traversal algorithm. Print the left subtree, print the root node, print the right subtree. But with this extra check that if the left subtree doesn't exist, let's not print it. We can't print it. And if we tried to print it and left was null, this will say null pointer exception. It's basically a seg fault. Alright, so there's our print method. So let's go back to the tree class. So what do we need in a tree? We need one piece of data, which is the root, which is initialized to null.
But do you want to create a variable for representing the root, like root something equals new root or new node? I mean.
So we'll do that in the add method.
Okay.
All right. So let's suppose that our tree might already have some stuff in it. What does the print method do? So supposing that root's not null, how would we print the tree whose root is given by root?
Root.print.
Yeah. So this is a one-liner. If the root's not null, let's just call the root's print method. And what will that do? It will look for anything to the left of root and print that out. And then it'll print the root node's data. And then it will look for anything to the right of root and print that out. And that's exactly what we want in a left node right traversal of this tree. Alright, so there's our print method in the tree class, and it's really just a wrapper around the print method for the root node, but with an extra check to say, hey, if the root's null, there's nothing in the tree, we don't have to print anything, let's just return. Alright, let's do our add method. And so one thing you'll probably sense in Java is we have to deal with more edge cases ourselves, and I don't know exactly why that is, but it's something to do with encapsulation. It's something to do with the fact that we can't run a method and inside that method check to see if the argument is null, which is what we did in C, right? We're going to actually run the method as part of an object, and if that object is null, we can't run the method. So we have to do this checking for null before we call methods sometimes. So up here, for example, we have to see if left is non-null before we call left.print. Whereas in C, in our print method, we simply said, you know, if the thing we're trying to print is null, let's return. So sometimes it may feel like we're doing more of these edge case checks explicitly. That's kind of the nature of object-oriented design. All right, so for the add method, we're trying to add a node to our tree. So node exists, right? And we're saying, hey, there's a tree whose root is, you know, this node that we're sitting in right now, and we want to add something to the tree whose root is that node. So we're going to add to either the left or the right. So here's how this can be written. If n is less than data, we're going to add to the left. And normally, how would we do that? We would just say, let's go into the left subtree, call the add method. Right? And that would be that. So if we want to add to the left, we'll go to the left subtree's root, which is called left, and we'll use its add method to add n. But there's one way we could get into trouble here, which is what happens if left is null. If left is null, we try to run left.add, we'll get a null pointer exception. So if we're trying to add something to the left of the root, we need to do an extra check in here first and say, is there a left subtree? Sorry? No, let's not try catch. Let's check this explicitly. You could technically do it with a try catch, but I'm going to try to never use try catch unless it's absolutely necessary. So I'm just going to say if left is equal to null, then no, there is no left subtree. So just make a new node for the left. So left equals new node n, and we're done. So now what does this look like? If we're inserting to the left of the root, see if there's a subtree on the left. If there's not, then all we want to do is create a single node with this value n in it, and make that the left subtree of this current node. So we say left equals new node, and we're done. Otherwise, there's a subtree on the left. There's at least one node on the left. Let's just call that node's add method, and we'll insert into that left subtree in the proper way, and then we're done. All right, we're going to assume if it's not less than the data, then we're going to add to the right. We're not worrying about duplicates, so if it's not going on the left, it's going on the right. And so same question, is there a right subtree? If there's, if right is equal to null, then right should just become a new node with this data value n, and we'll return. Otherwise, yes, there is a right subtree, so use the right subtree's add method. So we'll say right.add n, and that's the end of our add method.
Why no return statement?
You can put it in. But since it's the last statement of my method, it's optional. But yeah, it's probably good practice to put it in.
What? No, it's a void method.
It's a what?
It's a void method. How would you put a return that's unused?
Yeah, but you can still return. Just don't return anything.
I know, but it already does the return. You just don't see it.
Yeah, and a good compiler will just chuck that. but you know, it saves the possibility of you know, kind of like not doing your curly brackets on if statements. Potentially you might decide to do something after here and not realize that it should return right there. So I kind of like having it in there, I guess. Personal preference. You get like lots of freedom in how you do this stuff. That's part of why I think programming is so fun. It's your canvas, it's your paintbrush and paint. As long as people like the end result, you know. Alright, so there's the add method. And add, you know, is a method inside the node class. So in our tree class, how do we add something? So if the root is not null, just call root.add. Because root's a node, and nodes come with add methods. So if the root exists, let's just call root's add method. But we have this one possibility, which is if tree is empty, then root is null. Well, how do we add to an empty tree? We simply create a single node. If our tree is empty to begin with and we want to add the number n to it, we just create one node with the value of n and we make that the root. So if the tree is empty, then the root is null. So just set root equal to new node n, and then just return there. So I'll leave the return off this time, just for balance. So there's an add method. And that should round out our tree class. And so barring typos and algorithmic glitches, this should compile and run. So if I compile this, I get all of my class files. And then when I run main, there's our in-order traversal, and you can see that the numbers we added to the tree came out in increasing order, which is what we were expecting. And so we've you know, implemented a simplified tree class. And again, most of the work happens in the node class. And the tree class itself is mostly just wrappers and a place to keep the root, which is a node. Most of what we want to do, most of the operations are done on the root. And the edge cases are where the root is null, in which cases we mostly just, you know, do something manually to the root node in the tree class itself. Either create a new node or you know, not print anything or whatever. All right, so that stuff is on the server if you want to reference it for sample code, and use that as kind of a starting point or an inspiration for your binary tree in PA3. The main differences being you're going to have a string for your data, and that's going to be typically a question or an answer. You're going to have a yes child, and you're going to have a no child. And you might have some other stuff in there. If you want a Boolean to tell you if you're a question or an answer, you could put that inside the node, and so on. but the rest of it's pretty much the same. Now for the traversal, when you want to create your file on disk, we do a pre-order traversal, node left, right, and that's no harder than this. Just do your print in the beginning and then do the left and right subtree traversals. So go ahead.
Can you show us how we can construct a tree from the data in the file?
Yes. So the ingest process is a little funky. So let's do a read tree.
Just want to double check to make that you're recording, yes.
Yes, it is running. Thank you. Never a bad idea to check.
Imagine the first 52 minutes and nothing's recording.
Oh yeah, it's happened.
Horrible. Please now. God forbid.
Yeah, no, that's happened before, or you know, I'll record it, but there'll be like no audio, or things like that. So so when I'm doing class, I've got this window sitting on the side, so I can see I got audio going, and I can see what's actually being recorded. Because sometimes I'll do this and it records an empty screen, you know, or it'll record, but there'll be no audio or things like that. So hopefully, you know, this is fairly reliable these days. All right, so
Someone should build a program that does like accurate lip reading, so that if you forgot to turn your microphone on and got audio, then the transcript will still be.
that would be cool. Actually, I think Zoom, you know, if you use Zoom's recording, it'll transcribe for you, I believe. But yeah, that doesn't help if the microphone goes south. Yeah, that would be useful. And then, you know, you're up to HAL 9000 at that point. So, all right, so read tree. We're going to open a scanner constructed from the file name 20q.txt or whatever file you're using. So you're going to open a scanner. You're going to pass that to your read tree method. And read tree basically does the following. So, you know, QA line. So let's read QA line from SC. And then read text line from SC. So if we actually look at, like, you know, the sample file, it might have a Q colon followed by is it an animal, A colon followed by cat, A colon followed by laptop. So these first two reads, this line in this case would read Q colon, and this would read is it an animal. All right, and so now we do the following. If QA line is A, if it's an answer, then make a node with text equal to whatever the text line was. So make a node, I'll just call it node. Set the text equal to the text line. So, you know, I'm thinking of a node like this. Set yes equal to no equal to null. And then let's return node. So this read tree method should return a node. And so if your file happens to begin with an A colon followed by an answer, read tree just returns a single node, a tree with just a root node containing that text and no children. But if that first line had read the QA line was not an A colon, we can assume it's a Q colon. Now we do two recursive calls. And we say make a new node. And we'll call this node. And we'll set the text field equal to, what you read in as text line. But we'll set the yes field equal to the return from another call to read tree. So we'll recursively call read tree. That'll return a node. We'll set the yes child of our current node equal to that. And then we'll call read tree a second time, recursively. And we'll take the tree that comes back, the node, and we'll store that in no. And then we'll return this node that we just created. That's your whole read tree algorithm.
So again, question, like two of them.
Mm-hmm.
So for on the second line, we're starting with the word read. What does that say?
Read text line from SC.
Yeah, it's just the handwriting was harder to read, so I had to make sure I was taking this correctly.
Okay.
And down kind of near the end of your pseudocode, when you call yes or no, you're just calling the same method, but for the yes subtree and for the no subtree.
Mm-hmm.
So how do you can you remind me and say what how do you know which one goes in the yes and no subtree?
So call read tree recursively here. The tree that you get back, that goes in yes. And then call read tree again. The tree that comes back, that goes in no.
So is it kind of creating what you call threads? I think you might cover that later on with lecture.
No, you're doing these one after another. So read tree will start at the current point in the input file because you're passing the same scanner that you got here, right? So it'll start at the current point in the input file, and it will read until it's gotten to the end of a tree, and all of that gets returned. That's what yes is set equal to. And then when you call read tree again, it will start where it left off in the input file and read down until it's read another tree, and all of that will get returned, and that's what no will point to. And this is a bit of magic.
Yeah, it is magical, but
So we make this node. Where do we put it?
Which node?
So if view line is A, it says make a node, right? We make a node, which is then we return the node.
Yeah, so node n equals new node, n.text equals text line, n.yes equals n.no equals null, return n, for example.
Okay. Where do we call this read tree from?
From whatever method you're having when you want to ingest a tree from a file. So typically in the beginning of your play a game method, you're going to tell, play a game what the name of the database file is, and it's going to open up that file with a scanner, and then, say root node equals read tree parentheses scanner object. And then, root node is the thing that you start with when you want to play the game. So look at root node. If it's a question, ask the question, get a yes, no, move to the yes or no child, and keep going until the node you're looking at is an answer, and then tell the person the answer. So this is just the ingest phase. This is just building the decision tree from a text file.
and in some words to say like, no, I was thinking about this object here. Would you try and create a separate method for adding things to a file in case you get like a no answer?
So you're never going to manipulate the file other than doing a node left-right traversal. You never, ever, ever, ever want to try to monkey with the file any other way, because the organization of the file is really hard for us to understand. What you want to do is, in the very beginning, open your file, read it, and build a tree using this algorithm. Play the game from the tree. If the answer is wrong at the end, get the, do the dialogue with the user, update your tree in memory. And then, once your tree in memory has been updated, write it out to a file using that node left-right traversal.
So when you say stored in memory, are we just kind of taking I'm trying to figure out how that's gonna work. Can you show me how that works on paper?
No, I don't know how to do that. But when I talk about having the tree in memory, I'm talking about, you know, you have a variable called root, for example, and root has a yes and a no field, and each of those is a node that could have yes and no fields, and there's data fields. That's what I mean by having a tree in memory, as opposed to, you know, this kind of peculiar PA3 business where we have a file on our hard drive containing the same information as the tree. We don't want to try to interact with this directly other than reading this in using this algorithm and creating this file by traversing the tree node left right and writing out this file as we traverse. So we read from the file in the very beginning, we play the game, we update the tree, and so on. Every time the tree changes, we write it back out to the file. But the file's just, you know, what we read from, what we write to. We don't do anything else with the file. And so what does your main program look like? We'll do pseudocode here, right? Check for argument. And figure out what the file name is that you're going to use. It's either 20q.txt, or if there's an argument, it's whatever the argument is. Root equals read tree. You know, open the scanner and from a file that's constructed with the file name, put it in a try-catch block and so on. Get a scanner object, pass that scanner object to read tree or whatever. This is pseudocode, but you know, first thing, figure out what the file name is that you want to read your tree from, and then use your read tree method in whatever way is appropriate to create a tree, which in this case I'm calling, you know, root. So this could be a tree or a node, but you know, get a binary tree, and then play the game with that tree. And maybe, you know, return a Boolean to tell you whether or not you win. And then maybe if you didn't win, then save your tree, and maybe pass the root and the file name, and you know, put this in a loop.
What does save tree do? Does it just take all the? Does it? I'm gonna assume that it takes the tree, you put it inside memory, or something like that.
So save tree is your node left right traversal of the tree. So traverse your tree pre-order, and at each node, instead of printing to standard out where the user would see it, write it into this file. So in the beginning of this, open up a print writer so you can write into that file, and pass the print writer to your recursive node left right method, and you know, print writer.println whatever the root node data is. And then if left is not null, do the left's save tree and do the right save tree. So a recursive pre-order traversal.
So you put save tree inside the tree class, correct?
You can put it anywhere you want. I'm not going to pin down where you should put things in classes or which classes you should have. You've got full creative control over that.
Okay. And so save tree is simply, it's kind of like what you did for the binary search tree of instead of printing them out, you're writing it into a file.
Exactly.
With the same order, like Q, A, and A, you know.
Mm-hmm.
I think, right? And
Yeah.
I'm assuming like, does it have to go at the very bottom of the file, so that way you play the game again, it would not read it incorrectly?
So to get it to read correctly, all you're allowed to do is write it out in node left right order. Don't try to get any fancier than that, or you're almost guaranteed to get tripped up. So read the first root node, right? And if it's a question, write a Q colon. If it's an answer, write an A colon. and then write the text field itself. And then if it's a question, it means that there's a yes node, so call the yes node's NLR traversal, which will write a bunch of other stuff into your file. And then call the no node's NLR traversal, which will write some more stuff into your file. Close the file and return. You're done. It's really about, 3 or 4 lines of code to do this whole save tree business. And it's a slight variation on this, right? I mean, the print comes first, but instead of system out print line, it's going to be whatever your print writer object is, dot print line. And instead of just printing a data field, you're going to print a Q or an A, and then on a new line, you're going to print the actual data from the node, which for no particular reason, we were just calling text in this example. But for example, when you look at the sample files, right? This particular file begins with a bunch of questions. Question. And then there's an answer. And there's a few answers. And then there's another question. And then there's another answer. And then there's 2 more questions. And then there's some answers. And we don't want to try to monkey with this file. For example, if you play the game and you get to the end and the answer was wrong, and you need to update that answer to be something different, it's very hard to tell where in this file that change is going to get made. Don't try to figure that out, right? Sometimes when you add a new question, it's going to end up at the very bottom of the file. Sometimes it'll end up in the middle of the file. So we're not going to try to understand how this file is organized. We're just going to create this file by doing a node left-right traversal, and we're going to ingest this file by doing this recursive, effectively a node left-right ingest.
So in other words, the file, or not in other words, but like, okay, so basically you want the file to only be in a pattern of like QAA and then QAA and so on. So, yeah, so that'll be a node left-right traversal, correct?
No, not at all. If your tree was perfectly symmetric, you could make a statement like that, but we have no idea what the shape of this tree is. So it could be, 100 Qs followed by 200 As, or it could be 100 Qs followed by 1 A, followed by another 50 Qs, followed by 60 As, followed by a bunch of QA pairs, right? But we don't need to understand that. Right? The file is simply something we read in the beginning and we write at the end. And we don't interact with it other than that. We don't use it when we're playing the game. We don't use it when we're adjusting our tree. We do all of that in memory. And so playing the game, here's some pseudocode for playing the game, right? Set temp equal to root. Well, temp is a question. Ask the question. Get yes, no. If yes, then temp equals temp dot yes. If it's a no, then temp equals temp dot no. Go back up. When you exit your while loop, you've got an answer. Tell the user the answer. Well, that's your basic gameplay loop. And this you want to get running before probably pretty much anything else. So start at the root. If it's a question, ask, get a response from the user, move to either the yes or no child, go back again. Keep doing this as long as the node you're sitting at is a question. When the node you're sitting at is an answer, you're done. Tell the user what the answer is. And then there's this extra stuff that I suggest putting closer to the end of this assignment, which is, tell the user the answer, find out if the answer was right or not. And if it's not, get the correct answer, get a question to discriminate, adjust your tree to add that question in place of the answer node, and then your game is smarter. And at the end of that adjustment, that's where I would call the node left-right traversal to update the file on the hard drive with the new decision tree. All right, let's do a 5-minute break, and we'll come back at 11:17. And I want to take a look at Eclipse and start thinking about PA4. So think about this. If you got more questions on PA3, let's talk about those after break. Otherwise, I want to look at where we're going next. So I'll be back in a few minutes. All right, we're back. Wow, this is crazy. So, you know, occasionally I like Coca-Cola, and Mexican Cokes have like sugar instead of high fructose corn syrup. And it's getting harder to find Mexican Coke from stores around here. So I ordered from Amazon, right, a 24 pack of 12-ounce Mexican Coca-Cola. And two problems. One, it's Canadian Coke, not Mexican, which has fructose, glucose, and sucrose. And two, there were 8-ounce bottles. And so I've been talking to the vendor, and they were like, sorry to hear about that. Would you like an exchange, or would you like a 10% refund? And, you know, 8 ounce instead of 12 ounces, that's 50% more that I paid for the soda, so a 10% refund doesn't work. And I wrote back and said, you know, I don't want this product at all. Please tell me how to exchange it for or get a full refund. And so they just wrote back and said, how about a 20% refund? And it's like, basic math, people, 50%, right? So math is good, but it's better if more people know it. All right, sorry, that was my little break. All right, any other things to talk about PA3 right now?
Expecting to come down to sour soon.
Okay, well, again, my usual suggestion, you know, is get in there and start writing some of this stuff. Make yourself a simple tree in memory with like 3 or 5 nodes, and work on playing the game, and get that running. And then do the traversal business, because you've done traversals a bunch of times now. And if you can write it out to a file, you can look at the file and see if it looks like, you know, the files you're supposed to be making. And then you can work on the ingest business. And once you have ingest working, then you can work with, you know, the pre-existing files, including the big file. You can make sure the game playing makes sense. And then you can go to that last piece, which is, you know, adjusting the tree at the end. But if any part of it is making sense right now, go ahead and code up that part of it, or those parts, and that'll give you something concrete to work with to start, you know, trying to understand the next steps.
Yeah, I think my plan is just to just to read the tree and then start playing the game. But when people have to know, I'm just gonna put a little temporary statement saying like I'm still developing. You know what? The thing you just said no.
Yeah, perfect.
Just because I feel like that implementing adding new information to the file is going to be tricky and a little bit. It could be. I would say it's a little bit technical or
Yeah.
something like that. It's like if you mess up like one small mess up and it's a big problem.
Sure. And so if you work on the parts for playing the game, and then maybe work on the parts for writing out the file, what will happen through that is you'll get more comfortable with, you know, the data structure itself, the classes you're developing to work with this, and so on. And that'll all make it easier when you get to, you know, this business of, well, let's adjust the tree now to add this new information to it. So going in cold, you know, is just an extra layer of complexity on that. So warm up to it, right? Do some of the other parts that you have a better idea how to do, and it will make it it'll make it easier when you get to those later stages. All right, so PAs 4 and 5, we're going to switch to using an IDE, and we're going to use Eclipse. And you're going to want to stick with Eclipse, even if you're an IntelliJ fan or Visual this or that, right? We want you to come out of this course with a knowledge of Eclipse. Some courses may require this down the road. Some jobs may require this. Eclipse has been around forever. It's not the best IDE in the world, okay? There's plenty of problems with it. There's problems with most IDEs. But it's you know, been an industry standard in the past. And it's a good starting point because it does a fairly good job of getting out of your way when you want to do your own thing, but then being there when you want the benefits of an IDE. So we're going to use Eclipse, and I want to go through kind of a start to finish example of installing Eclipse, Java, Swing, and windowbuilder, right? And these are the pieces we'll be using for PA4 and 5. And I also want to do this on a VirtualBox installation of Linux, because the cleanest way to deal with all of this is on a completely native Linux system that does not have Eclipse or Java or any of the stuff pre-installed. Now, if you've already got, Eclipse running on your system, this will probably still work, but it can get tricky. Sometimes versions can conflict with one another and so on and so forth. And if you don't want to, scrub all of that stuff from your system and start over, you always have the option of running in VirtualBox. And even on a kind of old laptop, running Linux on VirtualBox will run pretty quickly. In fact, running Windows on VirtualBox is sometimes faster than running Windows native, which is really bizarre, but it seems to be true. So a good starting point, and possibly the ending point, would be just plan to run a VirtualBox on top of whatever system you're using, even if you're using Linux already. If you want a clean install, this is not a bad way to go. So I'm going to go through this kind of start to finish, and I've tried to do at least most of this recently, but not all of it. So we're playing without a safety net here, so things might blow up. And this is on par with what your experience might be. So I'm just going to start from VirtualBox, and hopefully people downloaded VirtualBox in 224, but maybe you haven't used it or haven't used it in a while and such. So I'm just going to start with a completely clean setup. I'm going to actually get rid of this. Yeah.
VirtualBox, for me, I find it really tricky to install because it requires like storage, it requires some kind of drivers and so on and so forth. It can be very tricky to install. So
What's your operating system? Are you on Windows?
yeah, Windows 10.
It should go pretty painlessly, ideally, theoretically.
Yeah, just because
Do you have an old computer?
mine's not old.
Yeah, if it's Windows 10, that should be modern enough.
You can get PCs from like 2005 on Windows 10.
That's true.
Yeah.
So definitely let's work on it in office hours if you're having problems. It sounds like maybe you finally got it to install though.
Yeah, I got to install. It's just I need some kind of like I/O disk or something like that. It requires like multiple pieces.
There's lots of things it will suggest to you that aren't actually required, but it sort of depends how smooth an experience you want. For example, you can open up a shared folder, or you can enable copy and paste between your virtual machine and the outside world. But if you kind of put yourself inside VirtualBox, I mean, you can run Canvas from inside VirtualBox to pull down the assignment and so on and so forth. You can sort of live inside that environment to a large degree. You can SSH from there to the server and pull files back and forth like that and so on. So if you've got a VirtualBox running, you should be good, but definitely let's screen share offline, and if there's other issues that should be taken care of, we can go over how to do that.
Alright, sounds good.
Cool. Alright, so I'm going to say new, and I'm going to call this 223 Wednesday, and I'm going to say the type of system is going to be Linux. I'm going to do 64-bit. I don't care what my folder is because I'm going to delete it after class probably. The memory is important, so depending on how much memory you have in your machine, right, 1 gigabyte of memory is a little lean. I'm just going to go up to 4. I've got 16 to play with, but I'll go up to 4. If you've only got 4 gig on your system, don't allocate 4 gig for VirtualBox because it'll kill your system. But I would do like half your memory for this. And maybe just plan on when you're doing this, don't be doing, a bunch of gaming or browsing or things like that in the rest of your system. And then most of this I'm just going to click through and take the defaults. I'll take the default there, I'll take the default there. I don't even know what these things are, I'm just taking defaults. Alright, and so you get a new machine here called 223 Wednesday, and I'm going to say start. And you kind of only get one shot to do this right. which is to select a startup disk. If you skip through this step, I haven't figured out how to go back and redo it, so I start from the beginning. But here, what I want to do is I want to pick a disk image for Linux. And so you can click on this, and you can search through your file system.
Real quick.
Yeah, go ahead.
So I just opened VS Code, which is what I use for a lot of things, and there's an SSH plugin, and it appears I'm able to SSH into the server and use VS Code
Okay.
natively from my Windows desktop
Mm-hmm.
to edit code on the server,
Okay.
as well as do command line.
Is there a question in there, or are you just noting that?
That was it. I was just
Okay. Yeah. So a few other people have done that. And other than why did this thing start on me? Other than wanting you to do stuff from the command line, that works fine. Although I've had a few cases where students had things die partway through, and they end up with several VS Code processes running. And then at some point they try to log in, and the system says you've got too many resources in use, and they're unable to log in. And then if they email me, I can go on and I can see, oh yeah, you got a process from November that's still out there and is using, X process slots, and I can kill those and get you back to normal. But I still prefer people are compiling with Java C and writing with VI and so on. Until PA4, and then PA4 I'm asking people to use Eclipse. So you can do whatever flavor of Linux you want. I've been doing Xubuntu for a while, and I've got a download here for 18. That's a long-term support version. 20 is the newer version. Any of those are fine, but download an ISO for your favorite version of Linux, and if you don't have a favorite version, you can spend some time exploring and find what you like. And most versions of Linux, are trying to be like Macs or Windows, and so they have splashy desktops with special effects and things like that. And you can kind of pick and choose what you want. If you want to get into some hacking and stuff, Kali is a really good version of Linux that has lots of tools related to doing things you might want to do if you want to dig inside your machine and so on. So I'm just going to do Xubuntu for no special reason other than it's pretty simple and straightforward. And so I'm going to say choose Xubuntu, and then I'm going to say start. And failed to open the session for, okay, whatever. And I think maybe I did too much talking and not enough responding to prompts, and something timed out. No, that's going. Alright, so I'm going to close this window out. Yeah. I'm not sure all my favorite Steam games play on Linux yet, but it's gotten a lot better. So if you were doing this on a physical device, right, you'd probably want to try it first and see if things like your network adapter work and so on and so forth. But since this is a virtual machine, we've got nothing to lose. I'm just going to go ahead and say install Xubuntu, which is this distribution. And then these will mostly be defaults for me, so I'll do the default keyboard. This will download updates while it's installing, so I'll take the default there. Again, if you were installing this, say, on your primary Windows machine and you were trying to install this alongside for a dual boot, this becomes really critical now, because this is where it's talking about where it's going to install it. I'm in a virtual machine right now. Worst I can do is clobber my virtual machine, which, didn't exist 3 minutes ago. I don't have anything to lose, so I'm going to go ahead and say install now. And it's going to give me a warning. If you continue, the changes listed below will be written to the disk. I'm fine with that because it's virtual. And it'll ask me a few more questions. It'll want to know my time zone, and it'll want some login information. So I'll go ahead with Los Angeles. And then for me, I'm just going to use my name, Nick. I don't care what the computer's name is. I'll use a frequently hacked password. And I'm going to say login automatically because, you know, I don't want to type my password every time. And then comes the bit of a long wait. So this will download a bunch of stuff and show you some splash screens to keep you entertained. But this will mostly just kind of run for a few minutes. So we'll let that go in the background. And we'll talk more about where we're going. So let me, on my real machine, bring up a browser window and show you where we're going to get to Eclipse and stuff. But we'll do this inside the VirtualBox once this is finished. So if you go to Google and just do Eclipse download, right, it should bring you to eclipse.org, and you have a number of options here. Make sure you trust your search engine. If you do this through, you know, a random search engine, you may get to something that's, you know, going to add something to your browser bar or install something or whatever. So eclipse.org, that's the Eclipse site. And what we're after is Eclipse Installer 2022-03. And it should say Eclipse Installer. That's the one that works best. If you just go to downloads, you got to hunt around for this. This is not the installer. This is the IDE, right? This is the runtime version and so on and so forth. So you best bet from Google, find Eclipse Installer 2022-03, and when you click to that, it should look like this. Try the Eclipse Installer, bold letters, 2022-03. And whichever operating system you're on, you could do this from Windows. I think it works best from Linux, so you can push files around and stuff like that. And
But kind of virtual machine, would you just use the Linux version?
yeah.
Okay.
Yeah, assuming that you did a VirtualBox and you installed Ubuntu or some version of Linux, then go ahead and do the Linux one. And it's a pretty small download, so I can download this. Don't have to donate any money. And there's my Minecraft resource packs. Hey. And so it's like 93 meg, so it takes a few minutes. Or 3 days.
So we download this on the Linux version?
So download this on the Linux. Yeah, I'm just doing this to like spend time productively while this thing is installing.
I see your internet is the same as mine.
Yeah, well, I think that's a slow download site. That's kind of unfortunate. Yeah, I finished uploading my 250 video, so it's not that. Or you can select a different download site. Well, that's a little better. Alright, so this is going to give us a version of Eclipse. And Eclipse is an IDE, so it's an integrated development environment. And inside Eclipse, we'll be able to say, for example, I want to create a Java project. And we'll give it a name. And it will create 1 billion files or so related to this project. And then we can say, I want to make a Java class. And we can say I want to make a class called main. And it will ultimately give us an editor window into which we can type our class information. I'm going to kill that download so that we don't spend all our bandwidth. This is getting there. So Eclipse will have an editor window, and you can type in your Java code there, and it will syntax check while you're typing. You can set it to compile automatically every time that you save your file. You can set it to save your file automatically, and you can hit a run button, and it will execute your main method in the class file. And it can be nice because, you know, for example, if you try to use a linked list, it will put a squiggly line under the linked list and say, hey, you need to import the linked list package. Would you like to do that? And you can say yes, and it'll go ahead and add the import statement for you. So it saves you a lot of typing and in some ways a lot of thinking. Alright, so we're done installing Ubuntu. You need to restart the computer, so we'll say restart. And this will sit here for like an hour until you realize it's waiting for you to press enter. So so press the enter key. And then it'll go ahead and reboot. And so this is the usual boot up that you would see if you were, you know, doing this on just a laptop or something. You'd see that splash screen and a message about checking the file system, and then it boots up. And it reminds you, you know, you can upgrade to version 20, and I'm just not going to bother with that right now. All right, so one thing I'm going to do is I'm going to come down under settings, and I'm going to hit display, and I'm going to make my display bigger, because 800 by 600, that's like, you know, 1990. So I'm just going to go with a nice big display and bring this over here. Alright, so I'm not going to worry about these updates. Let's go ahead and download Eclipse. So web browser is Firefox. I'll do Eclipse download. I'll do this again. And Eclipse installer 2022-03, and I will download that for Linux. I should have done it from a mirror. And I will save this, and that's pretty good download speed. Alright, I'm going to open the terminal window. So Control-Alt-T should always open a terminal, but you can also, you know, come up here and look for terminal and click on it. But I'm gonna open this up. And where does this do my downloads to? I know where it does it, but I want to see if we can see it. It should just be under my downloads directory. Alright, so there's where it's installing my my file it's downloading. And we'll just click on things to spend some time. So yeah, that's slowed down. That's a drag. All right. So so once this downloads, I'm going to unzip it. I'm going to untar it, and it will leave me a directory tree, and there'll be an eclipse-install inst that'll run, and that'll let me specify what I want to do. So let me tag some of this. VirtualBox, if you like. Eclipse 2022-03, I think they're calling it R. And I recommend the installer versus the IDE for a download, because the installer will give you options for what version of Java you want and so on and so forth. So when we run the installer, we're going to ask for Java OpenJDK, and we're going to want version 11. And I'm going to require that you use Java version 11 for PAs 4 and 5. And I want everybody on the same version. 8 is very reliable, but pretty old. And anything beyond 11 gets a little too newfangled for my taste right now. So we're going to do version 11. How's this doing? It's getting there. 2.5 minutes left. I'll play with my terminal window while we're waiting. There we go. And I feel like my window is a little too big. Getting there. 2/3 the way. All right, and this is you know, Linux. So I mean, we've got a hard drive, and you know, 138 things running, or you know, processes out there in the system. One of them running, which is the top command, Firefox, and so on and so forth. By default, GCC does not exist. So this is you know, not geared towards developers. It's geared towards the general public because people want, you know, Linux to be mainstream. So so it comes with, you know, some things installed and some things not. GCC is not installed by default. Anytime you want to install something, you can use this command, sudo apt install, and then the name of the thing that you want to install. And yeah, I made my window a little too big. And it'll ask you for a password, and it'll go ahead and install it. So GCC is not available by default. VI is. And most of the basic Linux commands, ls, and so on and so forth. Those are all available. How's our download doing? We've got 21 meg to go. We'll be there in a minute. Let me change my display size. Getting there. So when files are being downloaded in Linux, there's usually this file that it's loading into as a holding area, and it's called .part for partial. And once the file is complete, it'll get renamed to the actual file, and then this holding area will go away. So you can monitor it through your download itself, or you can just check for the file names. Doing this thing where it's slowing down at the end, that's a pain. We can pretend we're going to donate. We're not going to donate. We're not going to take the developer survey either, although we could. Alright, where are we? Alright, well, I'll keep talking. Sorry? The other...
We're saying that it depends on the way for download that when you have slow internet.
Yeah. Alright, so we're going to do Java OpenJDK version 11, and then we're going to want to install 2 packages into Eclipse. The first is called swing, and I'll show you how to install updates. It's pretty easy. It's under help. Just install software. And swing is a collection of packages, classes that we can use for creating user interfaces. So for creating windows and buttons and drop-down lists and for drawing and things like that. And so we're going to use Swing extensively to do the development of GUIs, and PA4 will be a graphics-based game that we're going to implement. So it'll have graphical elements, it'll interact with the mouse, and so on and so forth. We're also going to download a package called windowbuilder. And this is like a plug-in to, sorry?
I was saying, this sounds to be a very fun project to work on.
Oh yeah, definitely. This is like a plug-in to Eclipse that will let us design graphical elements using drag and drop. So from a command line using VI, we can create, you know, a GUI with buttons and give them colors and place them and so on and so forth. And it's kind of a pain. It's fun to do once. But most systems have a way to let you drag and drop components. If you want your button to be bigger, you just grab a corner and stretch it. If you want it to be yellow, you click on it and you find a drop down with a color palette and you click the yellow color and so on. And that's what windowbuilder is going to do for us. And so we're going to use windowbuilder to help us use Swing to create graphical interfaces. So that's where we're going. And we got the flashing blue arrow, so our download is done. So I'm going to close this.
About time.
About time. And if we do our ls, right, there's our tar file. And so it's Eclipse installer. So I'm going to G unzip that file, which leaves me a tar file. And I'm going to tar xvf that file. And it creates this whole directory tree of files sitting underneath this Eclipse installer directory. And in here, I'm just going to say eclipse-install. And so this brings up the actual installer. I don't know what oomph is, but it's fun to say. Eclipse installer by oomph. Alright, so here we want Eclipse IDE for Java developers. So let me tag this over here.
I've got a question. Should
Yeah.
I have the Secret Lab Titan Evo 22 or get the slightly cheaper 2020 version?
What are the two choices?
Secret Lab Titan Evo 2022. It's a chair. Or the Secret Lab Titan.
That's a profound question.
539, one's 494.
Oh,
Yeah, no.
huh. Depends how much sitting you do.
I do a lot of sitting.
Okay, go for comfort. Alright, I'm going to do Eclipse IDE for Java developers. That's us. We're doing Java development. IDE is the integrated development environment. Here's the really important part here, right? This drop-down box, choose Java 11. Alright, that's going to be critical. Otherwise, the versions of the class files you create are going to be meant for a later version of Java, and when I try to run this against Java 11, it'll complain at me. And I'll either have to upgrade Java or recompile your stuff and downgrade it, and either of those will not be good. So make sure you choose Java 11, right? Java Runtime Environment 11, and then installation folder. You can make that whatever you want. You can leave these if you want, and so on and so forth. Install, accept the agreement, having carefully read all of that. And this installation should be really fast compared to the download. So it's ripping through that.
Do you have a preference on what's the best integrated development environment for general projects?
Really the only two I've worked with to any degree are Eclipse and NetBeans. NetBeans is pretty much strictly Java. And Eclipse I've only used for Java and for some dedicated hardware like my Garmin watch. I've used IntelliJ in some form through Android Studio and haven't enjoyed it. But you know, if you really want to know my favorite IDE, it would probably be Arduino. And that was my first IDE, and it is so basic. They've amped it up recently, but it's really just kind of an integrated, editor, compiler, uploader, and so that's pretty harmless. MP Lab's not bad. I've been doing a lot more pick development lately, and have grown more fond of MP Lab as a result. So, but IDEs are like editors. There's so many versions, and everybody has their favorites and their pet peeves and so on.
Did you mention VS Code?
I've never tried VS Code, but I understand a lot of people really like it.
I don't really have any complaints about it. I mean, I use it for mostly web development.
Cool.
It's pretty awesome.
Yeah.
An Android Studio, I'll tell you that.
Okay. Well, yeah.
Android Studio is a cesspool.
Yeah, and it's better than it used to be.
Xcode is even worse.
Really, I've never tried that.
Xcode is like, oh, do yourself a favor, don't. You can't even click on Xcode to open Xcode.
Really?
You have to find the file to open Xcode.
Ugh.
Yeah, I don't. The first time I ever tried it, I was like, eh.
Yeah.
I click on the Xcode icon on the start menu, and it just does nothing.
Mm-hmm. That's useful. Wow, this is slow. This was fast when I did this before. And I posted a video a few days ago, actually a few nights ago. I was winding down. I just kind of went through this once and posted a quick video. And it's 2 minutes long or something. So this is running at a pokey speed today. But once this finishes, we'll get Eclipse up. Let me go ahead while this is going in the background and
Don't you have Eclipse already installed on your system somewhere where you don't have to wait for download and just kind of, I guess just kind of show the Eclipse without having to wait to install it?
yeah. And let me see if I can find it. Oh, we're done. Okay, we're good. All right, so let's go ahead and launch this thing, and embrace the full glory of the colorful splash screen. That is not actually an Eclipse as far as I can tell, but we'll let them slide. All right, so first thing, workspaces, right? Every project could go in its own workspace. So when you create a project in Eclipse, you're going to get a bunch of files. There's going to be source files, there's going to be compiled files, there's going to be configuration files, and you don't want them just kind of sitting all over the place. So I tend to work in one workspace, and since we're only doing a few projects, you can probably get away with that. But if you did, 100 projects and they're all in one workspace, it gets kind of hard to manage. But I'm just going to go ahead and take this default. Let me call it workspace. Yeah, we can just call it workspace because it's a new machine. So just take that default. Go ahead and launch Eclipse. There's another look at the splash screen. I'm going to close this window in the background. I'm going to maximize this. And so here's our Eclipse window.
Only took 20-30 minutes to install it.
Only took 20 or 30 minutes to install it. But once it's installed, you're good to go. So close out that's advertising. I'm going to close this. Let's do a really quick Java example, and then we'll go ahead and we'll dig into Swing and windowbuilder. So really quick start. I'm going to say File, New, Java Project. And uncheck this box, right? If you uncheck it once, it'll stay unchecked. But if you don't, it'll give you lots of backtalk. So uncheck this box down here. And then what do you want to call your project? I don't know. I'll just call it good stuff. All right. And leave everything else the same, but it's going to go under whatever workspace you specified. It's going to use Java 11 because that's what we did when we set up the installer. And I'm just going to say finish. All right, and we're good to go. Now, if I were to pop into a window, and I pop into Eclipse Workspace, I've got a new directory called Good Stuff. And if I look inside there, I've got two directories called bin and source. And those are both mostly empty, except I've also got a .settings directory which has this thing, and I've got a .class path and a .project. Don't monkey with this stuff, right? Stick with working from Eclipse. And this stuff is kind of, you know, it's like Git. When you work with Git, you want to use the Git commands. You don't want to go into the .git directory and start monkeying around, because if you mess this stuff up, then Eclipse will get confused. But if you're curious, right, you can see what's happening as you do different things in here. So we'll close that out. So I've got a project starter called Good Stuff. All my projects will get listed over here. If there's a little arrow, you can expand on it, and you can click through and see all kinds of things in here. But we want to just make a main program. So I'm
Libraries?
sorry.
Are those all Java libraries? Like
Yeah. So this is the runtime environment library for Java 11, and then source is where my actual source files will go. Alright, so here's what I'm going to do. I'm going to right click on my project, and I'm going to say new, and I'm going to say class. And I want to make a class. I'm going to be really unimaginative. I'm going to call my class main. You've seen me do that a bunch of times. It says up here the use of the default package is discouraged. Don't worry about that. We'll talk about packages another time. So I'm going to leave this blank. I'm going to ignore that message. The one thing you may want to do here, if this is going to be your main class and you're going to have a public static void main, you can check this box and it will create a public static void main for you. That can be useful. If not, you know, you can type it in by hand. You can have it generate comments for you. Okay, so I'm going to say finish, and here's my basic class file. So public class main, there's my public static void main, and there's a little comment in here to do. Right, I have to actually write my main method. All right, so I'm not in VI. I'm in a glorified version of Notepad right now. If you like that, you're all set. If you want, there's a package you can install called VWrapper. It might have a W in there. I'm not sure. You can search for it, and that basically gives you VI editing inside Eclipse. We'll stick with Notepad here. So let's just do a hello world. So I'll say public. And you know, it's underlining public because this is a syntax error because I haven't finished typing my stuff. But you know, if you don't like being yelled at while you're typing, then you won't like Eclipse. So public dot. And now it's telling me some things that I could put after the word public. Oh, I didn't want public at all. I wanted system. Dot. And now it's showing me some things I could put after system. I'm going to ignore that. I'm going to say out dot print line. And I'm going to type a left parentheses. And as soon as I do that, it types a right parenthesis. And you've got two options with IDEs. You can drink the Kool-Aid, right, and understand that, you know, I only need to type the stuff in between here, or you can just never look at your screen and just type as if you were in VI, right, and just say, I'm going to say, quote, hello world, and ignore the fact that it already put in a closing quote and a parentheses, and I'm just going to type those, and it's unhappy because there's no semicolon, so I'll put the semicolon, and now everything's good, right, so I've added my print statement, and here's my one line, you know, main method. Alright, if I want to run this, I can hit this run button. And when I click that, it'll say, do you want to save your changes? If you check this box, it'll always save when you run. It won't keep nagging you. So I'll check that and say OK. And my program runs, and here's my output on my console window. And so we've got Java development going. And I could do, you know, a for loop for I equals 0, I less than 10, I plus plus. Let's print out hello world. And do that 10 times. And now if I run this, it printed out hello world 10 times. Oh, hold on one sec.
Oh, sorry. I thought he was going to message me.
Hello. I want in my supposed to be the class. No, I'm still on.
Sorry.
Oh, I'm sorry. That's
I was
okay.
waiting for your text.
All right. So we got Java. We're up on the air. And you can do, whatever you normally do in Java. But like I say, this can make life a little easier for you. So for example, if I say linked list angle bracket integer list, if I just put my mouse over this, it will say linked list cannot be resolved to a type, and there's 6 quick fixes available. The first one, import linked list from java.utility. If I just click on that, it makes my import statement for me. And so, this absolves you of having to know what package are linked lists in, what package are hash maps in, and so on and so forth. If I don't do angle bracket integer, it will put a yellow line under this, and it'll say linked list is a raw type. References to generic type linked list angle bracket E should be parameterized. So, I can add type arguments to linked list. Well, if I do that, it will add the curly bracket with the angle brackets with a question mark, and I can just type in, the type of thing I want. So this is all, stuff that's beneficial to more efficient development. But I think counter beneficial to, actually learning a language. But our goals in PA4, PA5 will be to start doing a lot of Java development and get some really cool, high-powered behaviors coming out the other side. So we'll take advantage of, the more rapid development we can do inside here. And it's a usual IDE. So my source files are listed under here. If I made a new class, it would show up under here. If I make changes, I get a little asterisk on the tab. I can Control S to save my changes, and so on and so forth. Alright, let's install more software. So I'm going to go under Help, and I'm going to say Install New Software. And work with, I need to say what sort of repository I want to come from. I'm going to pick the first one, 2022-03. And under here, I'm going to say swing. And I'll let it find whatever's available. And I'm going to check both of these. Or I could just check that box. And I'll click through to next. And I'll click through to next, and I'll accept the terms of the license agreement and say finish. And this will take a minute or two. And your only sign that it's doing anything is this message down here, installing software. So you can keep typing and doing stuff. And you can run your code and stuff like that, and it'll keep installing in the background. And it goes from 0 to 49, and then it finishes. So we'll go ahead and restart. And this will give us the swing package, which is this whole collection of classes related to making windows. And then we're going to install one more thing, which is windowbuilder. And I left the box checked that said put something on my desktop, so I can just click that to start. Alright, so we'll go under Help. We'll say Install New Software. Work with, we'll pick 2022-03. And we'll say windowbuilder. And I think it's a separate install. And I'm just going to click all of those and say next. And next, and accept the terms, and finish. And it always jumps to 49, then it goes to 53, and it hangs out, and then it jumps up to the 80s, and it's done. I don't know why.
I'm kind of wondering, when they develop, a little loading bar like that, is there some code where somebody will sometimes even put in a little print statement or a output statement of where it is in the code?
I don't know if it's something that, when it finishes this part, it updates the status, or if something else is running and checking some flags to say how far it's done. But progress bars are never like, they never feel like they are what they should be, to me at least, because they're measuring something other than time, and I sort of want a progress bar in terms of time. If you tell me you're half done, I kind of expect, it's going to take the same amount of time to finish, as opposed to, well, I did one of the two tasks, and the first task takes 5 seconds, the second task takes all day. All right, we are ready to go now. So all of that is basically one-time setup, right? I've got my Linux system. I can boot that up. That should boot up pretty quickly. I can run Eclipse by just clicking on this. And all of our software should be good to go. So let me close this project, and let me just get you. We got 4 minutes. Let me just show you a first example of doing something with swing. So let me make a new project. I'll just call this S main. And instead of making a new class, I'm going to say right click, new. And I'm going to come down here and say other, and I'm going to come down and expand window builder, and I'm going to come down and expand swing designer, and I'm going to come down here and I'm going to say JFrame. And I can call it whatever I want. I'll just call it main, and I'll say finish. Alright. We've got a whole bunch of code now which has been written for us by window builder. And if we run this, we get a little window. And it doesn't do much. We can resize it if we're good at grabbing a corner. And we can close it, and when we close it, our program exits. But that's basically all it takes to get a window up and going. And if I go into my design tab down here by clicking design, then we get into this drag drop interface where we can take our window and we can start dropping components onto it. So I'm going to add an absolute layout manager, and I'm going to take a button and I'm going to drop it right here. And I'm going to call it, click me. And now if I run my Java code, I get a window and it's got a little clickable button. And by dragging this over and calling it click me and so on, what happened was Window Builder created a bunch more code for me. It created a line of code here which says, J button button click me equals new J button parentheses click me. Well, J button is a class. It's a class from Swing, and it creates a clickable button. And when you construct it, if you specify a string in the constructor, that becomes the label on the button. And if I change this to, ha ha ha, and I run my code, I get a window with a clickable button, and the clickable button says ha ha ha. So we go through the pain of setting up the IDE and installing the software and so on, but once we get to this point, we're going to be able to do really, really rapid development. And I mean, we got a window up with a clickable button already, and it took, almost no time. And if I want to do something when you click on the button, I can just double click on this. It'll bring me into a section of code, and inside here I can say something like system out print line hello. And now when I run my code and I get my window with my clickable button, if I click the button, my console down here is going to display the message hello. So now I got actions hooked up between, actions on my widgets and things that are happening in code. And that's really all we need to start building graphical applications. So that was a really quick preview. But next week, Monday, we're going to back up a little bit and talk about some more of the mechanics of Java that make all of this possible. We're going to talk about class extensions, and maybe we'll talk about packages and some things like that. And then we're going to start very slowly, methodically, doing the kinds of stuff that we just did here as a quick demo. which is, seeing how we can create a basic graphical window from Java, and then we'll start looking at dropping components onto it and so on and so forth. So this was kind of the flash preview of all of that, but we'll go through this more methodically beginning on Monday. And then that'll lead us into PA4 and PA5. All right, that does us for today. So have a great day, everybody, and I will see you in office hours, or I will see you next week. Hope you have a good one.
Have a wonderful evening.
All right, thanks. You too.
That's pretty cool, not gonna lie.
Awesome. Yeah, it's a lot of fun.